Geometry is the study of relationships between points, lines, surfaces, and solids. The relationships of their properties can be measured and compared with special algebraic equations called formulas. We will be using this reference sheet throughout the rest of this unit, which lists some of the commonly used formulas in geometry. Let's review the names of some basic shapes and their corresponding formulas. First, compare the shapes on the left to those on the right of the page. The ones on the left are two-dimensional, or flat, while the ones on the right are three-dimensional. We have a parallelogram, triangle, trapezoid, circle, prism, right cylinder, sphere, and right cone, square, pyramid, and some other formulas down below the page that you'll be getting to later when you take geometry. In lesson 7.2, we are going to focus on the measurements of the polygons on the left, the two-dimensional shapes. A parallelogram, such as a parallelogram, a square, a rectangle, a diamond, or a triangle, or a trapezoid, are all called polygons. A polygon is simply a three or more sided figure that is two-dimensional and enclosed. And the most common measurements of polygons are perimeter and area. Perimeter is the distance around the sides of a polygon. You will use addition when you're calculating the perimeter. Area is the amount of space inside a polygon, and you'll use multiplication. Another word for addition is plus. To help you remember that when you're calculating perimeter, you will add, think of the word plus. Perimeter and plus both start with P. So let's look at the first polygon, a rectangle, which is one of the parallelograms, and let's calculate its perimeter. So the perimeter is just the distance all the way around the polygon. So we need to know this side plus this side plus this side plus this side. But we notice what we are given are only two sides of the rectangle. If you ever do not know one side of a shape, simply look for the side that is parallel to it. For example, this 12 is parallel to this side over here. Therefore, the other side of this rectangle is also 12 centimeters. Same with the 3. If we see that this side of the rectangle is 3 centimeters, we look straight across from it at the line that's parallel to it, and we can see that it's the same distance, it's 3 centimeters. Now we know all the sides of the rectangle, and we can calculate its perimeter. So to calculate the perimeter, you need to add 12 plus 12 and 3 plus 3. Or another way to think of it is because you have two 12s and two 3s, is you have 2 times 12 plus 2 times 3. A formula that's often to represent the perimeter of a rectangle is P for perimeter is equal to 2 lengths plus 2 widths. I'll color code that for you so that you can see the 2 lengths, the 12s, and the 2 widths. So what is 2 times 12? Or 12 plus 12? Either way, you should get the same answer. 12 plus 12 is 24, or 2 times 12 is 24. It's the same thing. So we're halfway there. 2 lengths equals 24, plus our two widths. Our two widths are 3 and 3. Well, what's 3 plus 3, or 2 times 3 is 6. Now add them together. What do you get? 24 plus 6 is 30. So our perimeter is 30. If you didn't get all that, I rewrote it again and wrote down P equals 30 and showed how I got it. 3 plus 3 plus 12 plus 12 is 30. If you ever can't remember the word perimeter and plus, think of the military. Have you ever heard in a movie, sergeant or soldier, secure the perimeter of the base? What they want them to do is to go around the building. If you can imagine the rectangle as a building, you would add up each side. So the other type of measurement that we use when we are comparing polygons is the area. Unlike perimeter, which is the outside of the shape, the area is the inside of the shape. So for area, we need to use a formula. The formula for the area of any parallelogram, which includes a rectangle, is area equals BH, or base times height is what it stands for. So the base, that B, stands for the bottom of the shape. It could also be the top because it should be the same length. The H stands for the height of the shape. Now this is important, so listen carefully. The height of any shape in any formula is always the highest point straight down. So for this rectangle, this line represents the height, the highest point straight down. For the square, that's the highest point straight down. Be careful on the parallelogram though. A diagonal line is never the height of a shape. The parallelogram, the highest point straight down, would be like this. So it's often either represented with a line that's on the outside of the shape, just a little bit lighter or dashed down, or it could be on the inside, again, lighter or dashed down. Here, let me see if I can draw it better for you. Just a second. There, I've drawn two straight lines from the highest point straight down. So if they give you an additional line, that additional line is to help you to see what the height of the shape is. Let's go back to our rectangle. So the area of that rectangle is equal to the base times the height. The letters there, A, B, and H, are your variables. So we fill in what information we are given. If you remember when we evaluated expressions before, they told us evaluate the expression when x is equal to this, y is equal to whatever, and so on and so forth. Well, instead of them just telling you, they're going to show you with a picture. So, area. We don't know what the area is. We're going to leave it as an A. But do we know what the base is? Well, normally when we think of base, we look at the bottom. But if we don't know that length, then again, look at the parallel line to it. Oh, the 3. So that means our base is equal to 3. Now we need to multiply by the height. And it's going to be a number. But if we were to write a number here, it would look like, well, the height there is 12. If we just wrote a 12 there, our number would look like 312. We don't want to write that, or we don't want to make it look that way. So the way to represent multiplication of two numbers when they're after you fill in your variables is by using parentheses like this. We usually put the parenthesis on the second number. So this represents 3 times 12. Well, we'd have to multiply 3 times 12. 3 times 2 is 6. 3 times 1 is 3. So 36. Now, the other thing I need to address with you are labels. When you are given a label, as far as the unit of measurement, you must label your answer as well. So our perimeter, what did we say that was again? I've already forgotten. Just a second. It was 30, right? Okay, so our labels. Let's look at the unit of measurement that was used here. The unit of measurement was centimeters. Well, perimeter is just a straight distance, so our answer would be 30 centimeters all the way around. Area is a little bit different. We use centimeters, but because this is a two-dimensional a length and a width, and we want to know how much is inside area, you would say it's 36 centimeters squared. You'll put the little 2 there. So it's important that you put the 2 on the centimeters when you are measuring area, and do not put the 2 on the centimeters when you're representing perimeter, or measuring perimeter and areas in centimeters and centimeters squared. A square is also a parallelogram because it has 2 sides that are parallel to one another. But it just so happens that all 4 sides of the shape are the same length. So it's a property you need to know about a square. Because like in this drawing here, we're told that only one side is 9 feet. They assume that you know that all sides of a square are the same length. Obviously, the side parallel to it would also be 9 feet, but you also have 9 feet on all sides. 9 feet, 9 feet, 9 feet. So if you were to calculate the perimeter of this shape, what would you do? You would need to plus or add the 9's together. 9 plus 9 plus 9 is 9 plus 9 plus 9 plus 9, or think of it as 9 times 4 is equal to 36. Now look at your units. What did they measure it in? Feet. So your final answer would be 36 feet. I guess I was supposed to write the formula there. The formula for the area of the square then would be 4 times any, that was the perimeter. The perimeter formula would be 4 times the length of any one side. The area of a square is just like the area of the parallelogram. It would be the base times the height. So the base is 4, or it's 9, and so is the height. So 9 times 9 is 81, and then you need to label your answer. What's the unit of measurement? Feet squared, because it's area. 81 feet squared. Let's look at the next polygon on your page, a triangle. The formula for the perimeter of the triangle is the same as the shapes of any other shape, is that you add up all the sides. So side 1 plus side 2 plus side 3, all 3 sides you add together. So to calculate the perimeter, you would do 6 plus 10 plus 8. What do you get when you get 6 plus 10 plus 8? Well, 6 plus 10 is 16, plus 8 more is 24. So 24 what? Because our triangle has units of measurements on it, it's 24 feet. There, I just recorded a different way for you. Now let's look at the area. Write down the formula from your formula sheet for area of a triangle. Area, or just A is fine to write, is 1/2 base times height. Now, if you don't like to work with fractions, that's fine. This formula can be written one other way that probably will make sense for you that means the exact same thing. Instead of writing 1/2 base times height, you can rewrite it as base times height divided by 2. This formula is derived actually from the rectangle, because a triangle is nothing more than half of a rectangle. If you take any two triangles the same size and you put them together, you're going to get a rectangle. So if you cut it in half, you get a triangle. Take a rectangle and cut it in half, you get a triangle. So that's where the base and the height come from your rectangle, and then you divide it by 2. So let's look at the 3 numbers you see on this problem, the 6, the 8, and the 10. Now the base is probably pretty easy to see. The base is your 8. So you would write 8 times, we need a number there, that's why I'm going to write the parenthesis. Now be careful on this. Remember that your height is the distance from the highest point straight down. So what number would you write in parentheses? Did you say 6? The highest point straight down. Oops, the highest point straight down is the 6, not the 10. Okay, your height will never be a diagonal line. And then don't forget to divide it by 2. So 8 times 6 is 48, divided by 2 is 24. So 24, 8 times 6 is 48. Divided, checking my own math there. What unit of measurement should you give this? Remember, this is area. It would be feet squared. Now, if you were all excited about using your fractions here, and you're like, oh, but I know how to use fractions, then you could still have solved it using the formula the way it's written, 1/2 base times height. Well, our base, again, as we said before, was 8, and our height was 6. So if you recall from our multiplication lessons, how do we multiply a fraction times whole numbers? Well, you can't. The first thing you need to do is change all your whole numbers into fractions. Then you can either multiply straight across the top and the bottom and reduce, or you can cross cancel first. So I know 2 can cross cancel with my 8, and it reduces to 1/4. And then multiply across. Well, 1 times 4 times 6 is 24. And 1 times 1 times 1 is 1, and any number over 1 is just itself, or 24. Okay, so I still get the same answer. The last shape we're going to take a look at is the circle. Now you may not think, well, how is that a polygon? It doesn't have sides. Well, there's a joke. All circles have 2 sides, an inside and an outside. Haha. The measurements that we use for a circle, we can still use the measurement of area to talk about, area to measure the amount inside of the shape. But the perimeter gets a new name when we refer to a circle. A perimeter is called, and on a circle is called the circumference. And we're not adding this time because we don't have straight sides to add together. The circumference of a circle is 2 times pi, we'll get to what pi means here in a minute, times r. So that little symbol, let's see if I can. So this symbol that looks like 2 straight lines with a wavy top is called pi. That symbol represents a decimal number that just keeps on going and going and going, but we usually always round it. It is 3.14. If you ever forget what pi is, remember that Pi Day comes 1 month after Heart Day. or Valentine's Day. What day is Valentine's Day? February 14th. Well, one day later is the Pi Day. There's also a joke to help you remember the formula for circumference. This formula, the teacher says pi r squared. And I told the teacher, no, they're not, they're round. Pi r, oops, sorry, that was area. I told you that joke a little too early. Area is pi r squared. So the teacher says pi r squared, and I said, no, they're not, they're round. So it's a little pun on words. R stands for the radius, or halfway across the circle. If I draw a lowercase r inside my circle, do you see it? So it's just halfway across to help me remember that that's the radius. The D stands for diameter. Let me write out these words too for you. R is for radius, R-A-D-I-U-S. And D stands for diameter. So all the way across is called the diameter. And look at this, I'm going to draw a capital D to help you remember. Diameter is all the way across, where radius, though, is only halfway across. There's that little R to help you. So think of a clock hand when you think of radius. Sorry. Oops. Think of a clock hand. Anywhere the clock hand can go, that's the radius. That's the radius. As long as it's going from the center of the circle. As long as it's starting from the center of the circle, that's the radius. So it doesn't matter which direction it's sticking out from. Halfway across from the center of the circle is called the radius. All the way across is the diameter. So that should be right through the center of the circle. That's the diameter. That's the diameter. So any which way you turn the line, as long as it's going through the center of the circle, that is your diameter. So let's use these two formulas. Erase a little bit so you can see. Alright, so first they want to know what is the perimeter of the circle. But we know that we're not going to call it perimeter, we're going to call it circumference. Alright, so what is the diameter of the shape here? Remember, the diameter is the distance all the way across. That 36 seems on the center and they have the line drawn all the way across. That refers to the diameter, 36 feet. If you remember that the radius is only halfway across, then if you know the diameter, you can calculate the radius. You simply divide it by 2. Remember, half of something is the same thing as dividing by 2. Well, 36 divided by 2. There, I did it longhand, but some of you probably already know it in the top of your head, is 18. So our radius is 18 feet. If we wanted to find out their circumference, we need to multiply that diameter by pi. So there's the formula for circumference. It's either pi times diameter. Pi is the number 3.14. It represents the number of times that the diameter can be wrapped around the circle. 3.14 times, so not quite 3.5, but a little bit less than that. 3.14 times. There's actually a ratio of that. So if we were to calculate the circumference, we need to use the formula instead of perimeter. We're going to call it C instead of P. Circumference equals pi times our diameter. Or you can use pi times 2 radiuses. Because what is 2 radiuses? If we multiply our radius by 2, it will always equal our diameter, our 36. So you can use either one of those formulas to solve for circumference. Please use a calculator here. Otherwise, you could get round-off errors. There is a button on your calculator with the pi symbol on it. Unless your directions tell you specifically, use 3.14, use the pi button on your calculator. All computers have a calculator application. If you go to your Start menu, you can look for Calculator. Please ask your teacher or a neighbor to help you find your calculator on your computer. Here I have the calculator up, and notice I don't have a pi button on this calculator, but what you can do is go to View and Scientific, and there we have a scientific calculator. Now this scientific calculator unfortunately does not have the fraction button that our calculators that we have in class have, but it should have the pi button, and there it is right here. So on your handheld calculator, that's the symbol that you're looking for. Sometimes you have to use the shift key. So if I need to calculate what our pi is, so I click pi, and it gives us this great big long decimal. There's that 3.14 part, times our diameter of 36 equals, and we get this great big long number. So our circumference is 113.09 whatever. Normally when you have questions that ask for circumference, it'll ask you to round either to the nearest whole unit or to the nearest, they'll have you round, okay? So 113.09 rounded to the nearest whole unit would just be 113. So we can just round that up. So our perimeter and the answer should be 113 feet, because it's a linear distance. Alright, now we're ready to look at the area of the circle. So the area of the circle, what is the formula? Look at your formula sheet. Area equals pi r squared this time. So to calculate it, again you can use your pi button on your calculator, or you would have to use the number 3.14, and you're going to multiply that times your radius, which we found out was 16, but we have to square it. So you need to use the square button on your calculator. It's important to remember the order of operations here. You would not type 3.14 times 16 first and then square. Remember, you have to solve your exponents first. So 16 squared, that's the same thing as 16 times 16, or if you use your X and Y button on your calculator, please use calculator in this unit. We're trying to find out what 16 square is, so I'm going to type in my 16, and then I have an X to the 2 button I'm going to click. It's 16 square is 256. So I'm going to write 256 and multiply that by my pi. Remember, I'm probably going to get a decimal number, and let's just round to the nearest whole foot. What's nice is after you do your exponent, you can just leave that number in your calculator and go straight to the multiplication. So I'm going to type times and then click on my pi symbol, pi. Now when I clicked on pi on this computer calculator, oops, I'm sorry, you can't see it right now. Just a second, let me make it so you can see what I'm doing. So there was my 256 in the calculator, and then I multiply it by pi. That's that 3.14. I'm not done until I hit the equals. There I get 804.2477. Let's round that to the nearest whole unit. What do you get? So when you round to the nearest whole number, you're looking for that decimal point, and what number comes before the decimal? I see a 2 there. That's lower than 5, so 5 or higher you round up, otherwise you stay the same. And so rounding just means you round off all those off to zeros, and your answer is just 804. So 804 what? What's the unit? It was feet. So feet, and then because we're doing area again, it's feet squared. 804 feet squared. Alright, it's your turn to practice these now. Don't forget your units, and try problems 5, 6, and 7, where they talk about a scenario. What I recommend you do whenever you have a story problem in geometry, that you draw a picture of the shape that they're describing. Good luck with these, and don't forget to self-check and correct.